What's up guys and welcome to this new video about implementing and visualizing an algorithm in Kotlin. In this video we will build such a simple application which shows a list, and when we click on the sort list button then it will apply the Bubblesort algorithm, and we can see on the UI what's currently going on, because we will manually delay each step of this algorithm and then we can emit in a flow chain each step of this algorithm and process these values and show it on the UI. Let me quickly show you this. When I click on sort list, then it indicates which items are currently compared to each other, and when they need to be swapped, then we have a little animation. In case you don't know what the bubble sort algorithm does, I will explain this when we implement this right now. Maybe you already know it. It's not the most complex one, and it's also not the most efficient one. There are also other sorting algorithms which are way better than the bubble sort algorithm, but I think this is a cool example to actually show how such an algorithm visualization can possibly be implemented. Alright, okay, I'm in an empty Jetpack Compose project. In case you use XML for your layouts, then you should be also able to follow along, because we will only implement a button and a list in Jetpack Compose. You can also apply this in XML, and most of the logic will happen in a view model and in a use case where our actual sorting happens. The only thing I did was to add two colors, gray and orange, for our background color and for the button color. Then we can go back to our main activity and remove this default stuff, just that it's done. We won't implement the UI yet. We will first take care of the algorithm. Let's go to our root package for that and create a new package called domain, because such a sorting algorithm should be, of course, implemented in the domain in the business layer. So we will make a package for this layer to simulate this layer, kind of, and in the domain layer we will have a package called model, where our domain models are into. And here we can create a new Kotlin class called sortinfo. This will be a data class and contains three properties. The first property will be the current item of type integer. The second property will be should swap of type boolean. And the third property will be had no effect of type boolean as well. Later, when we implement the algorithm, we can then emit values of this type to the view model, where it can be processed and we can show the user corresponding UI actions like highlighting, swapping of items, and all that stuff. Let me quickly explain you these three values, because they are very important. The current item property indicates which item we are currently looking at. So if it's in the array, the first item, second item, third item, and so on. The second property indicates if we should swap this item, which we are currently looking at, with the next item. And the third item, or the third property, is had no effect if we should not swap it. And we can of course get this information if this should swap is false, but there will be a situation where we need to differentiate between these two. We could also make this some kind of enum class, but yeah, I will explain you what I mean by this when we are in the view model and when we differentiate between these two values. Alright, okay, let's go to implement the algorithm. In our domain layer, we will create a new package called use case, because we will implement a use case, and our use case is applying the bubble sort algorithm. So we can call this use case simply bubble sort use case, like this. In here, we will make use of its operator function invoke. We can say operator function invoke. In case you didn't see this yet, we can later call this use case like this, bubble sort use case, and just pass the argument here. This will be our integer list like this, and we don't need to say something like start or something like this, because we will only have one function here, our use case, and therefore we should use such an operator function. This will take a list, which is a mutable list of type integer, and it will return a flow of type sortinfo. Let's import Kotlin X coroutine flow, and we can start, or we can build this flow with this flow builder. And then the first thing we need is a var list size to compare is equal to list.size -1. And I think now it's time to explain the bubble sort algorithm. Alright, okay. Let's take a look at this example. We have 5 steps here, and when applying the Bubblesort algorithm, we always start at the 0th index. We will have a look at 7, which is at index 0, and then this first item gets compared with the 1 index plus 1, so the 2 here with index 1. And if the first item is larger than the second item, then they get swapped, which leads us to step number 2. 2 and 7 are now swapped. And now 7 gets compared with 9, because 9 is the next item. We are currently looking at index 1, and 9 has index 2. And here 7 is not larger than 9, so they don't get swapped. And this will lead us to step number 3, where 9 now gets compared with 6, because we increase the index each step by 1, and now we are at index 2, where the 9 is, and then it gets compared with index number 3, the 6, and this time again they get swapped, and now we are at step number 4, and the last thing that needs to be compared is 9 and 4, and 9 is also larger than 4, so they also get swapped. And with this principle, we can be sure that after the first iteration of this step increases, we can be sure that the last item is really the highest one in the array, because only the highest item is able to pass all the comparisons to get always swapped. And it doesn't matter where the highest item is. If it's at the beginning, then it gets swapped all the time. Or if it's just at the end and some other item gets swapped until the end, but it does not get swapped when it gets compared to the highest item, when the highest item is at the end. So we can always be sure that the highest item is at the end after such an iteration. And then the next iteration, we again start at the beginning. In this beginning now, this is our current list. And then we start comparing the 2 to the 7. This does not get swapped. The 7 to the 6, which does get swapped. Then the 7 is here where my mouse actually is. And then it gets compared with 4, and they also get swapped. And then the 7 is here. And we don't need to compare it with the last item, because we already know that the last item is the highest one. So the algorithm stops here. And then the next step, we only need to compare these 3 items, because we know that the last item and the second last item are the highest ones, and we don't need to compare against them. And so it always decreases until only one item is left, and then the algorithm is finished. So the different items, they climb up like bubbles in the water. Alright, okay, back in Android Studio, we can now implement the algorithm. We will start with having a look at this list size to compare variable. This variable is exactly the indicator how far we should actually make the different comparisons, because we have seen after the first iteration, the last item was already the highest one. After the second iteration, the last 2 items were in a sorted order and were the 2 highest ones. So we only need to compare until them, and this list size to compare variable indicates how far we should actually go. And this is by default the list size -1. We will say while list size to compare is greater than 1. It's also our break conditioner, because we will decrease this by 1 each step. We can already write this down. Minus equal 1, and then this gets decreased each iteration, because each iteration we add 1 additional item at the end in the sorted order. And then we will say var inner iterator is equal to 0, and this indicates the item we are currently looking at, because we have seen we always start at the 0th item and then increase and go to the first item, to the second item, and so on. And this inner iterator indicates this item number. We will say while inner iterator is less than list size to compare, because list size to compare shows us how far we should actually move, and we only need to execute this while loop here until we are at the end of the necessary comparisons, which is indicated by the list size to compare. And at the end of this iteration, or at the end of this while loop, always we can increase the inner iterator by 1. And so that we move 1 step forward in each iteration of this while loop. So this is kind of a nested for loop, which also shows us that the time complexity of this algorithm is n to the power of 2. And then we can say val current list item is equal to list inner iterator, so the current item, and then we will say val next list item is equal to list inner iterator plus 1. And then we can start with our first flow emission. We can say emit sort info. Our current item is our inner iterator. Should swap. We don't know if we should swap yet, so we will pass false, and had no effect is also set to false. And then we can collect this flow later in our view model and show the user that these two items are currently compared by highlighting the border of the corresponding items. Alright, okay, then we will delay this a little bit so that we can see this highlighting of the current compared items a little bit, and after that we can continue and say current list item. If this is greater than our next list item, then they should get swapped. And for that we will say list.swap, and we will make this swap function an extension function. I'm not quite sure if there's already a native solution, but let's just quickly make this an extension function. We will say function generic type t, because this is needed, because such a mutable list always needs a generic type, and so that we can swap each kind of list. We will say swap and the index 1 of type int and the index 2 of type int as well. And we will say temp1 is equal to this dot this the index of index 1. Then we will set the index 1 to this index 2 and this index 2 to our temp1, and so we swap these two items at these two indexes. Then we can go back to our swap invoke and pass for the index 1 our inner iterator, and for index 2 our inner iterator plus 1. And after that we can emit again and inform the UI that we currently swapped the items. We will say sort info current item is equal to inner iterator, should swap is equal to true this time, and had no effect is equal to false. And if this is not the case, if the current list item is not greater than the next list item, we will simply emit again, and this time we will set should swap to false and had no effect to true. And after that, after this comparison, we can say delay by 500 milliseconds, so that we can also see the swapping of the two items in a smooth way. And don't immediately emit this sort info after we emit this one or this one. So this is why we have this delay. Alright, okay, now the algorithm is done. Not really complex, I think. And we can go now to our view model, collect this flow, and prepare everything for the UI. In our root package, we can create another package called presentation. And in here we will create our view model, because view model of course belongs to the presentation layer. And we will call this sort view model. And this view model will take a constructor argument, private val, Bubblesort use case, which we immediately initialize here. Normally we would do this with some kind of dependency injection framework, but I think this is fine for now. We will say var list to sort is equal to mutable state list of list UI item. This is a data class we didn't define yet. Let's go to presentation, create a new package called state, and in here we will create this data class called list UI item. And this list UI item will have an ID of type integer, is currently compared of type boolean, val value of type integer, and a corresponding color for each item. Then we can close this and go to our sort view model again and import the list UI item data class. After that we can initialize it. Normally we would get such a list from a database or from the network. In this case we will just initialize it with some random values. We will say for I in 0 until 9. So we will add 9 values to it, and then we can say list to sort dot add list UI item, and for the ID I think it's fine to just pass I, because each item is then unique. We need this uniqueness later in our UI for this swap animation. After that, we will set is currently compared to false by default. The value will be from the range from 0 to 150 dot random, so it will pick some value in this range. And then we also need to define the color. This will be 255 for the red part of the color, so that it always has the full red part. And then we will say 0 to 130, for example, dot random for the green or blue part, I think. It's the green part. And the same thing for the blue part. Or no, for the blue part we say until 70, and for the alpha we will pass again 255. And so our list to sort is initialized in this init block. After that we can define a function called start sorting. In here we will say viewModel scope, and we don't have that because we need to inherit from viewModel for that. Like this, we will say viewModel scope dot launch, and then we can say Bubblesort use case, and now we can invoke this use case like this because we made this an operator function. We will pass our list to sort dot map, and we are only interested in the values, so we will say list UI item dot value. We only need to sort the integer values, so this is fine. And we also need to say to mutable list because the use case expects a mutable list and not an immutable one. Then we can say collect and collect the flow and get each emitted sort info item here. Let's call this sort info like this. And then we can say val current item index is equal to our sort info dot current item. With this item index, we can now update our list to sort. We can say list to sort current item index is equal to list to sort current item indexed dot copy is currently compared is equal to true, because now we know that this item is currently compared, and we can copy and paste this. And here we can say current item index plus 1, and here we can say this as well. So these are the two items which are currently compared to each other, and in the UI we can then highlight them with a white border, for example, like in the demo app. After that we can say if sort info dot should swap, and this condition is only true 500 milliseconds after we have set this to true. So we have a really little delay here. And then we can say val first item is equal to list to sort current item index dot copy is currently compared to false, because now they should only be swapped. They are already compared to each other. And down here we can then say list to sort current item index is equal to list to sort current item index plus 1 again, and again copy is currently compared is equal to false. And the last thing is list to sort current item index plus 1 is equal to first item. Maybe this is familiar to you. This is also kind of a swapping function. Swapping two items requires always 3 different lines of code like this. The last thing that's left in our view model is to check if sort info dot had no effect. And in this case, we can copy these two lines from above and paste them down here. Is currently compared to false, and here to false as well. This is required because in some cases all items are not always swapped, and currently there is currently compared property is only set to false here when the items are actually swapped. We also need to set them to false when they are not swapped to each other, but we can't do this in this else block because in the first emission of our use case here, where we emit the current item, the should swap is false. And if we would use this else block, then they would be set to true and immediately would be set to false. And so we couldn't highlight them properly. And this is why we have this had no effect, which we set to true after this delay of 500 milliseconds if we enter this else branch. Okay, all right, let's remove this else again. And now let's go to our UI and implement everything there. And then we are good to go to try this out. In our main activity, we will first get a reference to our view model. We will say private val sort view model is equal to sort view model, like this. In the Bubblesort theme, we will then have a column with a modifier. And let's import column first. The modifier will be set to modifier.fillMaxSize. The background will be gray. The padding will be 20 dp. And we will also have to import dp and gray. And then we have a horizontal alignment, center horizontally, vertical arrangement, arrangement dot spaced by 10 dp. Really not that great UI here, I know, but I think for the demonstration it's fine. First of all, we will have a button in this column. Let's import that, and the onClick method will be set to sort view model dot start sorting. And then we will also have a text which shows the visualization or is the defined visualization of this button. The text will be sort list. The font weight will be font weight.bold. The font size will be 22 sp. Below this button, we will have a lazy column. And for the content, we will pass then our items. But first of all, I want to set a little bit of vertical arrangement. Arrangement.spaced by 15 dp. In here, we will have our items. And they come from our sort view model .list to sort. This is a mutable state list. So the lazy column gets updated each time such an item of this state list changes. And we will also pass a key which allows us for this smooth swap animation later. And for the key, a unique ID is required. So we can say it.id like this. And I think we first need to open this and import items, and then the arrow is gone. So in the key block, we get the list UI item. In case you prefer names here, you could also say item and then item.id. I will leave this like this because we have also the it reference inside this lazy item scope later. So this will be consistent. We will say val border stroke is equal to if it dot is currently compared. If our item is currently compared, we can initialize this with a border stroke with a width of 3 dp. And the color will be white. And if this is not the case, we will say border stroke width is equal to 0 dp. And just to be sure, because we still have a little border when we say 0 dp, I'm not quite sure why this happens, but well, we can just set this to transparent, and then there won't be any border stroke. After that, we will create a box, and the modifier of this box will be set to modifier.size 60 dp. The background will be it.color, and we will also have a rounded corner shape for this background with 15 dp like this. And then we will have the border. There we pass our border stroke, and this will have also a rounded corner shape of 15 dp. Then we will have the animate item placement, and this will make sure that the items actually get swapped. In here, we need to pass an animation spec, which will be a tween, and the duration will be 300 milliseconds. For the box, we can say content alignment, alignment.center, and I think we need to annotate this with experimental foundation API. This is fine for this tutorial. And then we can open the box scope, and we will have a text for each item, which simply says it.value. The font weight will be font weight.bold, and the font size will be 22 sp. And after that, we can try this out, I think, and hope everything works. Alright, okay, I forgot to make this button at the top orange, but I think we can try this out anyway. Let's click on this, and now we can see that the swapping and also the indicating which items are currently compared to each other is working very cool. And now in the second iteration, it should only go to the second last item and then starts from the beginning. Yes, it does. And now it should only go to the 7th item and then start from the beginning again. Yes, it does. So I think the visualization works pretty good. And also to demonstrate how this algorithm works, it's always better to have a visualization like this. and not looking at some pseudocode or yeah, Wikipedia entries and something like this. Okay, all right. I think this was it for this video. I hope you enjoyed it and you could learn something. Maybe you have also algorithms which you want to visualize. Let me know in the comments if you want to see an additional video where we visualize more complex algorithms like quicksort, for example. And yeah, see us then.